All right, we are going to do the Algebra 2 Semester 1 final review via video. That way you guys can stop and fast forward, rewind, wherever you need to. So here we go. First, question number 1. Gloria had some money in a jar, then decided to put $15 each month into the jar. After 1 year, she counted the money in her jar and she had a total of $320. Choose a recursive formula to model the scenario. So we see that she's got some money in a jar. It's important information. We also see that she puts $15 a month into the jar. 1 year later, she has $320. Now, if you notice, these are all recursive formulas using the previous term to generate the next. What we need to find out is what our initial value is. When x is 0, what will be that y? So what that initial value, the y-intercept, all that of this graph. So if she ends up with 320 and she puts in $15 each month for an entire year, those are the numbers we need to work with. 1 year is 12 months. So we can do 15 times 12, and as a result, we get $180. After 1 year, she has a total of $180 that she has deposited in. Problem, I need to know what the initial amount was. So if she ends with 320 after the first year, if I subtract that 180, I see that she started with $140. This now eliminates A and D. My next choice is either multiplying by 15 or adding 15. She's simply adding $15 each month. This would suggest that she's taking her previous amount, multiplying it by 15, and adding that much into it on top of what she already has. This is simply just adding that $15 every single month. So this would be the choice of C. Now, if she wanted to write this explicit, since this is recursive, she can write an explicit formula for this based off of this equation. This right here is the slope. That's my y-intercept. 0 for x, 140 for y. That's the y-intercept. So it could be un equals 15n, making sure the variables match up, plus 140. That would be the explicit if needed. This next problem, this one is an exponential equation, and it is an explicit exponential. We know that this is y equals ab to the x, where a is my initial starting value and b is my increase or decrease. So a is my initial value, 50. So 0, 50 would be the initial. You can see that all 4 choices have that. Now, if I look at point 8, it seems to reason that I would need that somewhere in the equation. So, whereas the last problem was adding, because we're just simply adding 15 each month, this is actually taking the original value, the previous value, multiplying it by 0.8, and going ahead and getting our result, taking the previous and multiplying it by 0.8 to get the next. This looks like our likely choice. If you're not sure, you can double check using some basic math. So if we look, our 0 is 50. So n, which is our 0, and un comes out with our value. So when n is 0, my un is 50. So if I just get me a couple of values, taking the previous term, multiplying by 0.8 to generate the next. So we're going to multiply 50 times 0.8. We're going to take every value that we receive and multiply by 0.8 to generate the next. So remember, when you have your calculator, second plus 712 will reset it. You want to do that regularly. So if I take 50, multiply that by 0.8, I get 40. Then I'm going to multiply by 0.8 again, 32. Multiply by 0.8 again, and I get 25.6. So 50 times 0.8 will generate the value of 40. So it's 40 for the 1, 32, and 25.6. 32, 25.6. So this would be my table chart right here. I'm taking the previous term, multiplying by 0.8 to generate the next. 0.8 to generate the next, and so forth. So I could look at this and say that this one is actually exponential. exponential decay. And I say it's exponential decay, and my pen just went crazy, because the value here is less than 1. Now, when I have my value less than 1, I know it's exponential decay. You want to double check your numbers. We can simply take this, substitute it to our y equals in our calculator, hit second graph, and then we can find out if we're close enough, if we wrote the equation correctly. So I'm going to go into y equals, substitute in the value, raised to the x, make sure that that exponent's on the outside of the parentheses, not inside, and hit second graph. And you can see that our values actually match up for what we have on our table, meaning we did do the correct equation. I'm going to pause.
Oh, sorry.
It's fine.
Didn't mean to interrupt.
You're good.
But we noticed after reading.
Okay. So now we are at number 3. All right, choose the equation on the line that passes through the points of the arithmetic sequence. U0 equals 10, un equals un minus 1 minus 3, where n is greater than or equal to 1. Once again, this one right here is our recursive, and we are changing it into explicit. These are our explicit choices. When I look at this, remember that this right here would end up being my slope. And because it's 0, this is technically our coordinate 0, 10, which becomes my y-intercept. So I see this written up as negative 3x plus 10. My choice would be D. Number 4. Certain species of animal is endangered and its numbers are decreasing. So keyword here, decreasing. The function y equals 250 times 0.76 to the x models the situation. Write a recursive formula, describes the situation. So we should be able to do this based off the one we did a couple minutes ago. If I actually substitute in 0 for x, I see anything raised to the 0 power is 1. So my y would be 250. So when u is 0, I should have the value of 250. So that eliminates A and B. Nice, easy, now you're down to 50-50 shot. On this one, we're decreasing, multiplying by 0.76. We should realize that this is 0.76 here. Now, this means, as you can see, that we have decreased by 24%. That's because 100% minus 24% is 76%. Right now, it's a decimal, is 0.76. This, you'll see, is an increase by 24%. 100 plus 24 gives us the 1.24. Because remember, it's the 1 minus your rate change. You're either subtracting this rate change, or it's plus or minus, where we're adding that rate change. So if you notice this one here, recursive formula, you see that we're subtracting 4 from each term. Remember, it has to be consistent all the way across. So writing a recursive, we know we're using the previous to generate the next. We see that our first term is a negative 8, second, third, and fourth. So this negative 8 here would be correct for all of them. Now we're simply subtracting 4 to generate from one term to the next. So our final answer would be A. Notice they're saying n is greater than or equal to 2 because they've already given you the first term right here. This could also be seen as n greater than 1, meaning that we're finding the second, third, fourth, fifth. Equal to 2 would mean we're finding the second, third, fourth, fifth, and so on. All right, so we're now going to look at these two, and this one is actually number 6. We're going to do both of them. Use the following table of values to write both an equation and a recursive formula for each. So if I look at these here, if I go from negative 1 to 2, that is adding 3. 2 to 5, adding 3. 5 to 8, adding 3, 8 to 11, adding 3. Now, on this one here, since it's actually starting with the -2, we're actually going to write that as a -2 is going to be your -1 value. And then the recursive formula is an minus 1, adding the 3. And of course our third part for recursive, for n greater than or greater than -2, because this was our first one. Okay? Now, if I'm going to write that these are the recursive, I'm going to do recursive for this one. Going from -64 to -68, subtracting 4. You see that you're subtracting 4 for all of them, so I can write this recursive. Again, starting at -2 is a -64. Then an is going to be an minus 1, subtracting the 4. Remember that n minus 1 has to drop down below, can't be on the same line. And then again, this one is still for n greater than -2. So these are the recursive. Now I'm going to write the explicit. Once again, these would be my slope. The only trick here is this is not my y-intercept because it's not when your x is 0. This is my y-intercept. These are my y-intercepts. So I'll use the y-intercepts and the slopes to write an explicit. I'm going to write them as y equals, since it's with x and a y. Y equals 3x plus the 5 y-intercept. Y equals -4x, remember you got to keep that negative with it, minus the 72. Alright, placement exam for entrance into a math class yields a mean of 80 and a standard deviation of 10. Distribution of the scores is normal. So we have our normal bell curve for this. What percentage of scores lies between 60 and 80? So we have a mean of 80, standard deviation of 10. We want to know what lies between 60 and 80. So I'm going to go ahead and draw out my bell curve. Our standard bell curve. Right in the middle, that's our mean. Remember, that's our mu. We know that on either side we have 3 standard deviations if it's a normal bell curve. We can go a positive 1 standard deviation, 2, and 3 standard deviations. We can go to the left is subtracting, so our -1, -2, and -3 standard deviations. We also know that there's values in these, our percentages. 1 standard deviation away is 34.1% on either side. Now we're going to add the next percentage. 2 standard deviations away is 13.6. Standard is 13.6%. Okay? Now my next standard deviation away, 13.1%. And then 0.1. So they're trying to find out approximately how many scores lie between 60 and 80. So I'm going to go ahead and I'm going to clone this right here. I'm going to copy it so I can use it on any problem that comes up next. So I'm going to group everything together. Then I'm going to clone it so that I can take that one and use it on my next problem. Okay? Alright. Make sure I'm on the right problem still. Here we go. Okay. Alright. So I'm going to highlight all between 60 and 80. Well, first I've got to write all my values in. I know that if my mean is 80, that's right in the middle. Standard deviation of 10 means either way I'm either adding 10 or subtracting 10. So I'm going up to 90, 100, 110. I'm going to 70, 60, and 50. So now I want to go between 60 and 80 and look for that percentage of scores. when I add them up, it's about 47.7 roughly. So our final answer would be that 47.5%. Now, if you recall standard deviations, within one standard deviation lies 68% of the data, roughly. Within two standard deviations is 95% of the data. And then whenever we can just keep on adding those on. So this is about 99% of the data, and then our last little bit is roughly the full 100% of the data. So again, one standard deviation away, you're looking at about 68% of the data. If you want to go 2 standard deviations away, you're looking at roughly 95% of the data. 68%, 95. The last bit becomes the 99%. From here to here is 99%. And then our final would be 100%, including of all the data. So this one here, we have our mean of 50. When we read it, number of cookies and shipment bags are normally distributed with a mean of 50 and a standard deviation of 3. Well, we want to know between 47 and 53. So when we go in, we add these up. We're going to first go ahead and clone this again in case I need it for my next problem. So we have a couple of stats problems. All right, so we're going to start with our mean of 50, and then we're increasing by 3. We're also decreasing by 3. So I want to know between 47 and 53 cookies. This is 47, this is 53. Within one standard deviation is 68% of my data, always. 2 standard deviations is always 95, then 99, and our final 100%. And that's about a 99.8 actually. Now remember, you can also use the calculator for this. So if we go to our calculator, we can go to second bars. So remember, when you're doing any of these, you want to reset your calculator to make sure that you don't have any information stored in there that will cause your answers to come out incorrect. So we're going to go second bars. That gets us to distribute. Okay? And at this point, we're actually going to go down. Oh, no, sorry. Dadgummit. I know it's second bars. And we're going to go down to 2. Sorry, had a brain spasm. All right, we're going to go down to 2. If you remember how to do all this. We haven't done it in a while. Our lower would be the smaller value. So it's second bars. You come down to number 2, normal CDF. So number 2, normal CDF. Okay. So number 2, normal CDF, hit enter. Our lower is going to be our smallest value, which is 47. Our upper is our higher value we're looking for, 53. This again is our mean, represents our mu, our mean, 50, and then our standard deviation of 3. You then hit enter and enter again, and it will actually give you the percentage. Of course, it comes as a decimal. You must convert to a percentage. Remember, if you have to convert to percentage, you don't know how, you simply multiply by 100. All right, next one. Now we want to know what to value 68% of the data will fall. Well, we recall that 68% of the data is within one standard deviation of the mean. So we're looking for the data right over here. So if I look, I can start with the fact that we have, suppose data is normally distributed with a mean of 120. With a mean of 120, standard deviation of 30. So we start filling out mean in 120, standard deviation of 30. So we are simply adding 30 this way. We're subtracting 30 this way. So here we're going to subtract 30 and have 90, 60, and 30. So we want to know 68% of the data falls between 90 and 150. Our choice is B. All right, we now have this last one. We want to know what percentage scores lies between 60 and 80. So if I come back here, I'm going to take my bell curve once again and utilize that to help it make it easier for me. Just keep using the same one. You can just keep writing down if you have to. Placement exam yields a mean of 80, standard deviation of 10. It's normal, regular bell curve. Scores, we're looking for between 60 and 80. So we start again, filling out our bell curve. We have a mean of 80, deviation of 10. I'm looking for something between 60 and 80. So again, when I add these up, same value, that one's going to be our choice of D. I think there's a few I've accidentally copied over twice. All right. For a class of 30 students, 4 students are to be selected to serve on a school activities committee, which sampling method would represent a fair and representative view of opinions of the class. So we want a fair sample. Selecting the first 4 names on the class list, we're excluding a lot of students. Select the first 4 students to walk through the door for class. What about the students who come from farther away? It's not right to leave them out of the survey. Place the names of 30 students in a hat, mix them up, and select 4 names. Select the first 4 students who interrupt the lesson being taught in class on Tuesday. So our best choice for this one would obviously be C. You can also use a random number generator if needed. School counselor surveys 100 juniors at JFK High School to determine which elective courses to offer for them next year. What population is the counselor interested in? Now, if you recall, population you could also see as parameter. Parameter of interest is what we use to actually measure populations rather than stating just the population. You may see it as written as parameter. So we're surveying 100 juniors at JFK High School to determine this. So we're not doing all high school students, we're not doing the seniors, we're doing students at JFK High School, yes, but the high school juniors. So this is one of those really good, not trick questions, but forgotten the word for it. One of those questions where they'll put an answer that looks correct, but it's not correct. You have to read all 4 choices. Make sure you're always looking at all 4 choices before you make a choice on these multiple choices. Always look at all 4 choices. This is known as a distractor. This looks like the right choice until you read D and you realize D is correct. All right, in case we're stuck on what number we're on, we are now on number 13, choice A. Now, when I do these, I will only do a couple of them, and then you guys will be on your own for the rest. So I'm going to do A and B. And actually, I'm going to do A, B, and C. What the heck, I'll just do them all. All right, so when I do these, I like to separate them out. I do 1 and 2 together, and then I'll do 2 and 3. So I do 1 and 2, and I do 2 and 3. And if you want to circle them, however, whatever. So I line them up. Now remember, if you're missing any variable, you must substitute 0 for that variable. Now when I look at this, I've got to eliminate something. Well, when I look at my last one, it's got a Y and a Z left. And I know that I'm going to have to combine 2 and 3 together as well. And I can't eliminate X in my combination of 2 and 3. So here I'm going to decide to eliminate the Y's because I can't eliminate Z's because there's no 0 in this one. Or no 0 in that last one. So I'm going to multiply this entire line right here by a -2 to get rid of it. Now, I would multiply this by, or not negative 2, positive 2 to make these opposites, negative 4 and positive 4. What I do to show some of my students, however, if they're stuck, we just go ahead and take the values out. This is a 4, put the 4 out here, put the 2 out here. And when you do that, if they already have opposite signs, you're golden. Now you're going to distribute all the way across. So when I distribute all the way across, I have an 8x minus 8y plus 4z equals negative 28. Now if you could see that you just need to multiply this bottom line by 2, bottom equation, you could just do that. But if you're struggling with it, just take their coefficients, put them out in front, and distribute those all the way across. It will still simplify to the same answer no matter what. 16x minus or plus 8y plus 0 equals 4 times 14 is 4 times 4 is 16. Carry the 1 to make that a 56. Now when I add up my systems here, you're going to see that the y's are zeroing out. And now I'm looking at my x's and my z's and then the value. So 8 plus 16 is going to give me a 24x plus 4z equals, when I add this up, becomes a 28. Negative 28 plus 56. Again, if you struggle with any of that, you can simply use your calculator. Negative 28 plus 56, 56, enter. And you see that it's 28. All right, now I'm going to combine 2 and 3. So I have 4x plus 2y plus a 0 equals 14. And I have 0 minus 3y plus z equals negative 10. So I eliminated y on the left side. I must eliminate y on the right side. So you must eliminate the same variables. Must eliminate those same variables. All right, so now I'm going to go ahead and I look at this one and I say, all right, I have to get rid of the y's. So I'm going to put the 3 out here, the 2 out here. They already have opposite signs. So I'm good to go. And I distribute all the way across. 12x plus 6y plus 0 equals, and that becomes a 42. 0 minus 6y plus 2z equals negative 10. And I add up my systems. Y's are gone. 12x plus 2z equals 32. Now that I have these completed, I'm going to combine these two. So I'm going to put these two together. And I have a 24x plus 4z equals 28. 12x plus 2z equals 32. Well, I'm going to eliminate. And here, again, if you don't see it, you're going to take the 4 on the outside, the 2 on the outside. But I can see that all I need to do is multiply this bottom line equation by 2. Not just any 2, but a negative 2. If they have the same sign, I need one of them opposite. So I'm going to rewrite. Gone, gone. That equals 0. And if I look at this, 28 minus 64. So when I do subtraction like this in my head, I go ahead and I say, okay, to get from negative 64 to positive 64, that's a 4. That's a 60. To get from 28 to 60, I'm going to actually have to add 32. So it's actually a difference of 36. Once again, if you struggle, use your calculator and you see it's negative 36. This 0 does not equal 36. It's not true. Therefore, there are no solutions. These three lines are on a plane, 3D plane, that never intersects. Never intersect. So this one would be not true. If it was 0 equals 0, it'd be infinitely many solutions, meaning they're the exact same line. Now some students would see that right here, this negative 3y plus z, they can solve and move the 3y over and make that z equals 3y minus 10. Substitute that in for the z here, and then they're just working with the x and the y. And they can solve that down, and you will still get the exact same answer. Pause for a moment. Make sure. Yep, we're still recording. All right, let's move on to the next problem. All right, this is an instance where I can see I've automatically got a z value. So I'm going to go ahead, I'm going to divide by 5. And I get z equals negative 2. Since I know z is negative 2, I'm going to substitute that in for my z's in those equations. 6x plus 3y minus 3 times negative 2 equals negative 18. So this one becomes a positive 6, and then I subtract that 6 over. And I get 6x plus 3y equals, negative 24 when I subtract that 6. 18 plus 6 is 24, so it's a negative 24. When I substitute into the other equation, I have a 6x plus y plus 4 times negative 2 equals negative 28. 6x plus y minus 8 equals negative 28. Now I'm going to add over that 8, and I end up with 6x plus y equals negative 20. So I've already got my z value. Don't need that. What I need to do now is I need to take these two equations, this one right here, that I need to focus on, and I need to take this one right here that I need to focus on, and those are the two equations I'm going to put together. So at this point, I'm going to double page so we can get it all on one sheet. I'm going to take these two equations and put those together. 6x plus 3y equals negative 24. 6x plus y equals negative 20. Once again, if you struggle with understanding, you simply take your 6, whatever one you want to get rid of, take your 6's, put them outside. Since they're both the same sign, make one negative. Personally, I can look and see that I can just eliminate if this becomes a negative. But I have to distribute a negative all the way across, which means all those signs will change. Now when I add up my system, these zero out, I get a 2y equals negative 4. Dividing by 2, y is negative 2. So I've got my z, I've got my y, but I still have to find x. Doesn't matter which equation you use to find x. I usually like to use the equations that have the positive variable that I'm looking for. All are pretty much the same. So I'm just going to use that second one. Doesn't really matter. Oops. All right. So 6x plus y plus 4z equals negative 28. So I'm going to substitute in my z and my y. So it's plus and negative, which I hate plus negatives. I just simply do subtract. Makes it easier. Plus negatives, students tend to screw up. If it's a plus negative, make that a minus. Do not leave it as plus negatives. It really messes a lot of students up. Now this one is a 4 times the negative 2. All right, I'm going to make the screen larger so that we can work with this and see it easier. So I have a 6x minus 2. 4 times negative 2, no plus negatives, make that a negative 8. I'm going to combine my like terms. Then I'm going to add over my 10. 6x equals negative 18. Solving for x, I divide by 6. X is negative 3. So I now have all three coordinates. X is negative 3, y is negative 2, Z is -2. And when you write your coordinates, they're always going to be in alphabetical order. So it's a -3, -2, -2. Now, last thing I need to do is check them. You just substitute them in. I have a tendency just to use my calculator to check them very quickly to save time. 6 times x, so 6 times -3 plus 3 times my y, so 3 times -2 minus 3 times my z of -2. I hit enter, it's -18, I'm correct. 6 times -3 plus -2 plus 4 times -2, and I get -28, I'm correct. And I know that 5 times -2 is -10, so this becomes my final answer. Next up. So we're going to do 1, 2 again, and 2, 3 together. Now what's interesting is if I went ahead and changed all of these values, say this was something like an x plus y plus c equals -7. And I changed the values and made it 3x, 3y, and 3z. You simply multiply the 7 times the 3 to get 21. And that's going to be your difference. Sometimes you're only left with 2 equations. And if you're only left with 2 equations but 3 variables, go ahead and try to figure out which one you can eliminate the easiest. So that would have been a prime example on this one here. If you were just given these 2 equations, but you're given 3 variables, eliminate the x's. You're able to eliminate them immediately, and then you're going to work with the y's and the z's. And then you can look at it and say, oh, well, I know that these are always going to add up to a certain value. So if I look at these, I'm going to combine 1 and 2 together, and 2 and 3. I don't really see anything in here that I want to solve for by substitution. Nothing's a really nice, pretty look for me. So I'm going to put x minus 3y plus z equals -7. Then -4x minus 6z. And you'll notice I've made a mistake. My z's need to line up. If they don't line up, it's really difficult to do these problems. So I need a 0 in place of the y. You're going to see this again whenever we do long division and synthetic, that you've got to always represent every single term. If you don't represent them, you won't get the answer correct. All right. Well, I'm looking at this. It doesn't really matter at this point which one I eliminate, but I do see down here I have an x, y, and z, so it does not matter. I see here I don't have a y down here on the second equation, so I can't eliminate y. It's got to be a choice of x or z. I'm just going to choose x because it's in the front. A lot of students just say, I'm always going to do that one. This has a coefficient of 1. So the 1 comes out, the 4 comes out. They already have opposite signs, so when I distribute, I don't need any of them to be a negative. 4x minus 12y plus 4z equals -28. -4x plus 0 minus 6z equals 4. Now, I have seen some students who will go in and they'll put a z here, or not a z, but I'm sorry, that's a y. They'll put a y there, 0y, and then they get confused. If it's 0, just put 0. Do not add that variable in there. It does confuse students. So, going ahead and adding our systems, 0's out, -12y minus 2z equals -24. I eliminated x here. I must eliminate x when I do 2 and 3. I don't have a y in that second equation. Again, don't put that y with it. It tends to screw up students. Okay, so I'm now going to, again, I could see that I can multiply this bottom line equation by 2, and that'll give me a +4 to eliminate the x's. If you struggle with that, just take those coefficients and send them out. Again, opposite signs, so I don't need to worry about that. I get a -8x plus 0 minus 12z equals 8. +8x plus 12y plus 8z equals 16. I highly suggest when you do each of these steps on these 3x3s, stop after each step, double check your work. Because you make one mistake here, everything's wrong, you got to start all over, and it's very hard to find mistakes. Oftentimes students just start the whole problem over again. I believe that's a 24. All right, since I have these combined, I'm now going to put the two together. Negative 12y minus 2z equals negative 24. Positive 12y minus 4z equals 24. What's really great about this is the fact that my y's zero out immediately. I'm left with a negative 6z equals 0. Don't panic, we're solving for z here. Again, 0 divided by negative 6. You can divide by 0 by a number. You can't divide a 0 into a number. So I have that this is, of course, 0. Once again, if you struggle with just simple division, 0 divided by 6, don't panic, double check your work, use that calculator, make sure your numbers are accurate. All right, I now have z, but now I have to find x and y. So what I tend to do is I just kind of go up to the previous items that I was working with, because this has a z and this just has the y's. Once I get that y and z, then I go back up to an original. So first I'm going to go ahead and I'm going to use one of these two equations. I want to use I'm looking for y, so I'm going to use that second one because that y is positive. Doesn't matter, you'll get the same answer, but I tend to drop negatives, and since I drop negatives, I want to work with something that's easier for me to see. So I'm going to say 12y minus 4z equals 24. 12y minus 4 times 0 equals 24. 0 is gone, so I don't have to worry about that. I simply have 12y equals 24. Now I'm going to divide by 12 to get my 24, or I'm sorry, to get my y value. And I see that y is 2. Now I have my z and I have my y. Now I use an original to find the x. Doesn't matter which one. I kind of like the second one because it's simple. All it has in it is the x and the z. Now yes, it does have a negative x, and I tend to drop negatives. So if you want to, use the first or second one if you have that habit as well. So negative 4x minus 6 times 0 equals 4. Negative 4x minus 0 equals 4. So negative 4x equals 4. Dividing by negative 4, I get that x is negative 1. So the last thing I want to do is double check. Hopefully I didn't mess up because I didn't check as I went along. But it looks like I have negative 1, 2, and 0. So it looks like x, y, z is negative 1, 2, and 0. So negative 1, 2, and 0, and I'm going to double check. Yep, okay. So again, I'm going to just use my calculator just very quickly. Negative 1 minus 3 times 2, because side by side is multiplication, plus 0, gives me my negative 7. Good to go there. Negative 4 times negative 1 minus 6 times 0 gives me 4. Good to go. 2 times negative 1 plus 3 times 2 plus 2 times 0 gives me 4. I've done it correctly. I know that my final answer is correct. And again, this is my final answer. Check the battery. And we're still doing good. All right, still good. So let's go ahead and let's do this last one here. So this is D. So again, I'm going to do 1 and 2, 2 and 3 together. Okay? It's just the way that I like to work. 1 and 2, 2 and 3. So this is 1, 2, and 3. So I have 2x plus y minus z equals negative 5. For x minus 2y plus z equals 10. I'm not going to multiply by anything. I look at this and I automatically see that these z's are going to zero out. I also see I have a z in that third equation, so I'm able to eliminate z from the first two. So when I add this up, I get a 6x minus 1y equals 5. Now you'll never see the 1 in front of the y, like here, but if you want to put it in just to make sure you don't forget it, that's fine. All right, coming over here, we're going to do 2 and 3. 4x minus 2y plus z equals 10. 2x plus 3y plus 2z equals 3. Now I'm going to do a little higher level here. I can look at this and see that if I want to get rid of the z's, I want to eliminate them, I just need this to be a negative 2. So I'm just going to multiply the top line by negative 2. Now technically this is a 1 coefficient, so if you had to do the little other way, you have a 1 here, the 1 would come out, 2 would go out. You need opposite signs, so 1 would have to be a negative. I'm going to keep it the way that I've got it right now, just a little higher rigor. So I get negative 8x plus 4y minus 2z equals negative 20. 2x plus 3y plus 2z equals 3. So one of the biggest mistakes students make is they don't distribute that all the way across. Make sure it's all the way going all the way across when you distribute it. When I add my systems, negative 6x plus 7y, my z's are eliminated, and I have a negative 17. Back to what we've done on all the others, we're going to combine these two together. 6x minus 1y equals 5, negative 6x plus 7y equals negative 17. The awesome thing about this one here, my x's are eliminated. So I am left with a 6y equals negative 12. So I solve for my y by dividing by 6. Y is negative 2. Now, again, I'm going to go straight into this right here above it, no further, to get my next variable. Just look straight up, and we see we can get an x. I'm going to use that first equation simply because it just has a positive x, and I'm more comfortable with that. 6x minus 1 times a negative 2 gives me that 5. So 6x plus 2 is 5. Correct? Yeah. So this becomes positive 2. So now I'm going to subtract 2 from both sides. 6x equals 3. Kind of a little bit of an icky number, but it is correct. X is 1/2. Now I have my x, I have my y. Now I'm going to take these answers and I'm going to go all the way up to the very top to substitute in. I'm going to use that first one, looks good. 2x plus y minus z equals negative 5. So 2x plus y minus z equals negative 5. I'm going to double check, make sure I wrote that down right. And I did. Okay. So now we have our x, we have our y. We substitute them in. 2 times 1/2 plus a negative 2, so it's a minus 2 minus z equals negative 5. This becomes 1. 2 times 1/2. Combining my like terms, I get a negative 1 minus z equals negative 5. Adding that 1, negative z equals negative 4. Now I chose this one. I don't like looking for a negative variable, but I chose it because students tend to get stuck right here. This is technically a negative 1 in front of that z as the coefficient. So if I divide by negative 1, I see that z is going to be 4. So that when I write my coordinate out, 1/2, negative 2, 4. So I'm saying that x is 1/2, y is negative 2, z is 4. So let's double check to make sure that's correct. Once again, I pull out my calculator to double check everything so I can do this quickly. 2 times 1/2 is a 0.5, minus 2 minus 4 is going to give me negative 5. That's correct. 4 times 1/2 minus 2 times negative 2 plus 4 gives me 10. 2 times 1/2 plus 3 times negative 2 plus 2 times 4 gives me the 3. So I've done it correctly. My answer is correct of 1/2 negative 2, 4. All right, solve a system of linear equations to find the solution. So this is just like what we were just doing because it's eliminate. You can do elimination, you can solve by graphing, you can solve by substitution. So what I'm going to do is I'm going to show you all 3 ways to do this one. Elimination first, substitution, and then graphing. And it's always your choice. So the first thing we're going to do is elimination. So in order to do elimination, I've got to have my variables lined up. This first one here, the problem is that the x is on the wrong side. I need this in standard form, meaning my x and y values are on the left side. So I'm going to subtract x. So it becomes a negative x plus 2y, whoops, equal to 3. Now if I bring down my 2x plus y equals 4. So to solve this by elimination, I'm going to get rid of the x's. Reason? Already one is positive, one is a negative. So when I look at this, 2 comes out. This has a coefficient of 1, so a 1 comes out. They just switch. Already have a negative, so I don't need a sign. I get a negative 2x plus 4y equals 6. Make sure you distribute all the way across. 2x plus y equals 4. So at this point, my x's will eliminate. I have a 5y equals 10. And dividing by 5, I get that y is 2. So I have that my y value is 2. Now I simply need to find my x. Just use one of the equations again. Now I highly suggest you go to an original in case you accidentally screwed up when you substituted or moved things around. So I'm just going to use that second equation. It's 2x plus y equals 4. Once again, it doesn't matter which one you use. So 2x plus y equals 4. Substituting in my 2 for the y. And I'm solving for x. Subtracting 2. I have a 2x equals 2. And then dividing by 2, I get that x equals 1. So my coordinate should be a 1, 2. So the answer for this one would be B. And I can check. 2 times 2 is 4. 1 plus 3 is 4. 2 times 1 is 2 plus 2 is 4. So let's do substitution. If I'm going to do the substitution method, I need to choose which one I want to solve for. Now I always look for a variable that has a coefficient of 1. It's just the easiest. This one is, either one of these will be fine, either using this x or this y. I just don't like to deal with fractions. You still get the same answer, but I don't like to deal with fractions. So I'm going to take that second equation, solve it for y by subtracting 2x. Now this was my second equation. In order to substitute, I have to substitute into the other equation. If I substitute it back into the original, I'll get 0 equals 0, all real numbers. So I've got to go into this first equation. This is my y value. So my first equation is 2y equals x plus 3. So I'm going to take this, and it's going to substitute in for my y. This is y, this is y. Now, when you do this, make sure again you write it correctly. Make sure that you distribute this 2 all the way across to the parentheses. At this point, you should only have one variable left. That's why it's substitution. If it's a 3 by 3, you may have 2 variables left, depending on how you substituted and which one you solved for originally. So I'm just going to move items around. I'm going to subtract my 8 over here. I'm going to add or subtract my x over here. I tend to like my variable on the left side, even though that did make it negative. This becomes a negative 5. Solving for x, I divide by -5. I get that x is going to be 1. Now again, I just substitute in. Doesn't matter, we'll do the 2x plus y equals 4. So 2x plus y equals 4. So I'm going to substitute in my x equals 1. And I'm going to substitute that in. So I have a 2 plus y equals 4. Solving for y, I subtract 2, and I get that y equals 2. So you'll see that it's still the exact same answer. The last one we do is solving by graphing. Okay, so we'll solve this last one by graphing. In order to solve by graphing with your calculator, you've got to be into slope-intercept form. You must be in y equals mx plus b format. So if I look at the first one, 2y equals x plus 3, it's my first equation. I'm going to solve for y simply by dividing everything by 2. Y equals, this is a coefficient of 1. 1/2 x plus 3/2. This is the first equation that's going to go into my calculator. Taking my second equation, 2x plus y equals 4. I'm going to solve for y. Again, simply subtract 2x. Now what I see so many students still doing is trying to combine this and making this a 2x. These are not like terms, guys. That's got to have an x, meaning like terms, in order for them to be combined. So I'm going to put my slope first, and then my y-intercept. Honestly, will not matter when you put it into the calculator. So I'm going to go into my calculator. I'm going to go into y equals. I'm going to put 1 into y1 and 1 into y2. Then I hit, Then I hit graph. Second, trace, intersect. And you're going to have to do that. You're going to have to enter 3 times. And then you look for the word intersection. Okay. All right. So let's get both equations in. So I'm going to reset my calculator to make sure there's nothing in it. Y equals 1/2. I like to put all my fractions in parentheses just to make sure I don't screw anything up. 1/2 x plus 3/2. Second equation is -2x plus 4. Now I'm going to hit graph. I wait for them to stop. I wait for the squiggle here to stop. If I don't see it, I can always zoom, come down, hit out, and you can hit out, and it's going to zoom it back out for you so that you can see that. I see my intersection. I hit second trace intersect, which was number 5. Again, second trace, coming down to intersect. And then I'm going to hit enter 3 times. 1, 2,